Welcome to the Backend course. Hi, I'm Mohit Chabda, ex-Salesforce, ex-Walmart, and in today's video, we will talk about Lambdas and Streams in terms of backend development. Let's first see how Lambdas and Streams are useful in backend development. So Lambdas and Streams help you write more cleaner code, more readable code, and even more performant code for processing the data like filtering, mapping, sorting collections, and transforming API responses and much more. Now let's try to understand what are lambdas and streams. We will start with lambdas, and instead of showing you theory, I'll show you a coding example through which you will get more understanding, because in this course I want you to learn how to become a backend developer, not only the theory part. So I'll show you the code first, after which we will discuss about the basic theory. So here is an example of lambda. So firstly we'll check the code without using lambda, and then we will see how lambda will improve our code. So this is the first example. You can see we have used the list collection here. We covered about the collections and the generics in this video. In case you have any doubts, you can refer to this video. Okay, so this list collection is of type strings, and basically we are implementing a array list here. So it has values like Robin, Alex, and John. So after this we have done some processing here. Consumer is a functional interface which has been introduced in Java 8. We don't need to go in detail for that, but here we have created an anonymous inner class which is using this consumer functional interface. So this anonymous inner class is implementing this consumer functional interface. So when we say functional interface, it means like it has only one abstract method. So we need to implement that abstract method. So you can see here we have used the override annotation, and we have given the implementation of this accept method which is part of this interface. So this is the normal code. You can simply say we have used the anonymous inner class which implements an interface, and we have implemented the method of interface. The point to keep in mind for this example is that this interface was functional, or you can say the interface had only one method. So when there is only one method, we can use lambda, and now you will see this code will be reduced to one line of code here. So we have used same thing, names dot for each, but after that, instead of writing this complete anonymous inner class and implementing the method, giving the method name and then the complete implementation, we can rewrite it in this simple way. Now why did it work? Because there was only one method. So what we are doing here is we don't need to tell all the details here. We will just tell the argument name here. You can see we use the string name. So we are simply using that, and then we would use this arrow and then provide the functionality, what we want to do inside the method. There is no ambiguity because there was only one method. So what is a lambda expression? Lambda is basically an anonymous function, and when I say anonymous, it means a function without a name that you can use whenever a functional interface is expected. So what is a functional interface? Functional interface means interface which has only one abstract method. For example, we just saw the consumer interface. It had only one abstract method. So because it has only one abstract method, it would remove all the ambiguity. You can directly use that using lambda. So example of the functional interface, runnable is there, comparator, consumer, and then there are many more like that. So you need to remember we can use lambda when the interface has only one abstract method, because that is the reason we can do something like this without any ambiguity. We don't need to define the complete method name, the anonymous class. We can simply provide the argument name and then whatever the implementation we want to provide. So this is the syntax for using the lambda expression. It can be used where you have only one abstract method. And how you can use it? You simply provide the parameters first, then use this arrow, and then provide the body or the implementation part. Here you can see because we had only one parameter, you can see here. So we provided that, then we use this arrow, and then after that we provided the body. Because here we had only one line of body, we can skip the curly brackets, but in case there are multiple lines, we need to add the curly brackets. So this is the syntax that you need to remember for the lambda expression. Very simple, right? Just provide the parameters, then this arrow and then the body part. If there are multiple parameters, surround them by brackets, and if the body has multiple lines, surround them by curly bracket. But in case we have only single parameter or single body line, we can skip the brackets as well. Okay, so let me show you another example so that you get more understanding of how to use lambda expressions. So firstly, I'll show you the case where we are writing code without using lambda. So this is example 2, where first I am showing you without the use of lambda. So again, I am using a list collection here which is of type user, again an array list, and we are adding multiple users in the list. Okay, now what we want to do is like perform the sorting based on the name of the users. So we have used collections.sort. Inside that we have provided the users, and then we have this anonymous inner class again. So comparator is an interface. It has this one method compare. So you might have already used this compare function in your data structure algorithm problems or in your day-to-day work, where basically we want to perform the comparison for sorting. So here you can see we have just compared the names of two users based on which sorting will happen. Now let me show you how we will do this with lambda, but before that let me again paste the syntax here. So this is the syntax of how we will use the lambda. Now let me show you code with lambda. Alright, so this is the code with lambda. This part we have kept the same. This is just replacement for this part. Instead of mentioning the complete details like the anonymous inner class and then the method name, we can simply replace it by this. How we can do this? Because we are already using a method collections.sort which takes the particular parameters. It would require a collection and then the implementation of the comparator. So it already knows what will go inside. Hence we can skip all this work by this. So how we will rewrite is, first we have the collection, users is the array list name here, and then we use the sort method. Now in the lambda you can see we have this, right? In the first example we had only one parameter, so we skipped these brackets. But now you can see we have two parameters, u1, u2. So we will include the brackets here and then provide the parameters. So same to same the syntax we have done here. After that we will use this arrow, and once we have used this arrow we can provide the implementation or the body part. But because again the body is of one line, we can skip these brackets. We can simply write the code. You can see we have written the same code here, and in this one line we were able to perform our complete task. So you can see here lambda can replace a lot of your code. It will make your code more cleaner and more readable. So the major part to keep in mind is that it is for the functional interface, that is the interfaces which has only one abstract method, and after that we can simply use this kind of syntax to use the lambda expression. So after lambda, now let's move to streams. So streams allows you to process the collections in declarative way like we do in SQL, and that we can do without manually looping. I'll show you examples after this so that you get more clarity. Okay, so stream is not a data structure, it's a view over collection. So in streams we have two types of operation. First is the intermediate and other is the terminal. So the intermediate step would simply return the stream. The examples are map, filter, sorted, distinct, limit, skip. So all of these operations are intermediate, and then we have the terminal operation which is the end of the pipeline. So these are like collect, for each, reduce, count, find first. You might have already used some of these. So one important key point here is that the operations are lazy, which means they are executed only when a terminal operation is called. So we saw two types of operation, intermediate and terminal. Only when the terminal operation will be called, the complete things will be executed. Now let's see an example where you would be able to relate to it. So we are taking a backend use case where we would filter the active users. So you can imagine all such things like filtering, sorting, searching, all these operations are very frequently used in backend code. So we are taking such similar kind of example. So we have a list collection here of type users, and we are using the stream operation here. So you can see first we are applying the filter, and in that we have applied the condition that user should be active. So we are filtering only active users. So firstly we have done the filtering of active users. Then we are performing the sorting. So we have used the sorted method, and inside that we are using a comparator to sort based on the username. So it would do the sorting of the active users. And then finally we are using the collect method where we are collecting it to the list. So just to remind, like these were the two operations that we talked about. Here you can see we have used the filter operation, so that is the intermediate operation. Then we have used the sorted operation, which is also an intermediate operation. Then we have used the collect operation, which is a terminal operation. As we saw earlier, the terminal operation is required because the operations are lazy. They are executed only when a terminal operation is called. So we have called collect here, which is a terminal operation. So you can see here in such a small code we have performed so many things. Like we have done the filtering, we have performed the sorted operation, and we have collected it in a list as well. So that is why lambdas and streams are so much important in backend development. Otherwise you have to write so much of code which is not actually required, and this makes your code very clean, more readable and more performant. So this is a very common backend case where we perform filtering, sorting and collecting it to a list. If you're getting confused by this, don't worry, we will cover about this in the next video. This is the new feature that is introduced in Java 8. It is called method reference. When we say user and using these two columns and that get name, it is similar to using the lambda expression. We are doing user and then we are doing user dot get name. So this is what we are doing using the method reference feature of Java 8. We have converted it to this. So we will cover about this in the next video. I'll also cover about the functional interface and other things in the Java 8 features that we are going to use in backend. So don't worry about it for now. Now let's see another common example which is very frequently used in backend, which is to convert your DB entity to API safe DTOs. If you want to learn more about DTO, it was covered in this video. You can refer to this video related to DTOs. Now let's see that example. Here you can see we are doing the mapping to DTO. We don't want to expose our database entity directly to the API, so we want to map that to DTO. So again we are using a list collection here. The type we have kept as user DTO because finally we want to return in terms of DTO. So here we can imagine users as the data and we are performing the stream operations on it. First operation we are performing is the map operation, and this you can see is a lambda operation, right? So in this example we are talking about both of the things, the streams as well as use of lambdas. You can see we have this parameter, then this arrow we are using, and then this is the body. So basically what we are doing is mapping the database entity to a DTO. So we have created user DTO. Basically we are mapping the user, which is the database entity, to the DTO class that we have created in our code, which is kind of API user friendly. And then we have performed the collect operation where we are collecting the data to the list. So map is the intermediate operation and collect is the terminal operation. Now let's see another example of aggregation. Here you can see we have applied the stream operation on the users. First operation that we are performing is the filter operation where we are simply checking if the user is active, and then we have applied the count operation. So the filter is the intermediate operation and count is the terminal operation. So you can see we have performed our task so easily in couple of lines, and this code is so clean and readable. Here again this is the Java 8 feature method reference, which we will cover in the next video. It is actually same as using the lambda expression like this, user dot is active. So this was the old way to write in the lambda expression, and using the Java 8 feature we can rewrite it as this. This is the method reference. I'll talk about it in the next video. Now let's see some of the common places where we use lambdas and streams in backend. First is filtering API inputs. So you need to perform this action frequently in backend where you would remove the invalid or the null entries before saving it. Another case would be transforming the DB results into the API responses. This is similar to one of the examples that we just checked where we were converting the entity to the DTO mapping. Because we don't send the entity directly, we map it to the user friendly API DTO and then send it. Third one is related to grouping of reports. So this is also a very common example that I'm talking about. You can see we have taken the map collection here of type boolean and the list of user. Then we are performing the stream operation on the users, where we are using the terminal operation collect, and then we are grouping based on the active users. Another common example is joining the strings. Here you can see we have performed the stream operation on the users. First we have used the intermediate operation map. So basically we are fetching the names of the users and then using the collect operation, which is a terminal operation, and we are joining the names with the comma keyword. So all the usernames will come separated by comma and we will get that in a string. Now with that, let's see some of the best practices that you can keep in mind while using the streams and the lambdas. So the first one is try to keep the stream pipelines short and readable. If there is too much work that we are performing using the streams, it can get sometimes bit confusing. So try to keep it short and more readable. We have seen the example where we were able to perform a lot of operations in like one or couple of lines. Next point is use the method reference. For example, we used user and then the get name, so it gives you the method reference. So wherever possible use it, it will give more clarity. The next point is like avoid using streams for very performance critical code with millions of records. So it is not recommended to use stream. So in that case you can use batch processing. And last but not the least, don't overuse. Sometimes a plain loop is really more readable and easy to understand. Don't overcomplicate things just to use streams or lambda. If in case something can be done easily, that is fine. Okay, so we covered a lot of things here related to the streams and the lambdas in terms of backend development. We did not go into very basic level of these things because in this playlist we want to learn the backend development. So we are only covering things to the level where those would be required on the backend level. But in case you want detailed information about how to use lambdas and streams and want to know more about it, put that in the comment section. I'll create a separate video where I can give the complete details of that. If you found this video helpful, press the like button and share it with your friends so that all of us can learn and grow together. Alright then, this is Mohit Chabda signing off. Subscribe to the channel and thanks for watching.